Alright, so in this problem, in the figure below, triangle BAT is the image of triangle PIG of a similarity transformation. So the first thing you want to do is make sure you label the image and the pre-image correctly. So remember, it always tells you in the problem, triangle BAT is the image, and triangle PIG is obviously then the pre-image. So the first thing you should notice is that the triangles are not facing exactly the same way, which means you need to make sure you use the order of the letters to help you find your answers. So if we want to find the length of BA, what I like to do is highlight the length of BA, and then I also highlight its corresponding length in the other triangle. Okay? And then I pick another side in the image, so if I use BT corresponds to side PG. And then hopefully, if you do this correctly, your last side, IG, corresponds to AT. So then to find the length of BA, you have to set up a proportion. So you obviously have to have BA in one of your ratios. Since it's in the image, it should go on top of the fraction. So BA over BA corresponds to IG, so 8.5. And that's going to equal, and here's where you can just pick two other corresponding side lengths. If I picked 5 and 25/100ths, I would have to make sure I put that over 10. And from here, you just cross multiply. So when I check your paper, I'll have to make sure that you found BA, and please make sure you round to the nearest 10. So that's 1 decimal. So I'll be looking when you turn this in if you could solve that proportion. Alright, now the value of K, which is just the ratio of similitude, K is image over pre-image. So all you need are two numbers. So what I like to do is pick a number from the image. So if I picked, let's use 7 and 75/100ths this time, I would put that over its corresponding length in the pre-image, so 14 and 75/100ths. And what you would have to do is you can either leave it as a decimal, or I would like to see it as a simplified fraction. So I'll be looking for the length of BA and the value of K. Alright, remember you also need to tell us if this is a contraction or expansion. Contraction means that K is greater than 0 but less than 1, and expansion means that K is greater than 1. So you have to tell us which one it is, and you also have to explain. So this is how you could explain your answer. So we'll be checking that as well. Number 2, you have a parallelogram. So the big thing you need to know about your parallelograms are the properties. Opposite sides are equal. And in this case, that's the one we're going to use because they give us the side lengths. So all I'm going to do is start labeling my picture. X squared minus 5x plus 7. The length of DC is 2x plus 1. And the length of BC is 9x minus 1. Now, I've seen a lot of people adding all of these up and setting them equal to 360. Remember, the opposite sides are equal. We're not talking about angles right now. So you need to set the two opposite sides equal, and if you need to highlight them, that would be AB to DC, because those are the two side lengths that are the opposite. So you don't even need to use 9x minus 1. So x squared minus 5x plus 7. You guys are getting really good at solving these. 2x plus 1. So I would subtract 2x from both sides and subtract 1 from both sides. Then be careful with your addition. So then from here we get x squared minus 7x plus 6 equals 0. And this can be solved with simple factoring. So if we want to multiply to 6 but add to -7, -1 and -6, so x would equal 1 and x would equal 6. Now, we also now need to go back in and make sure that we get a positive side length. So you just need to check at least 2, because if you check DC, AB is the same as DC. So what I would do is I would check DC with 1, so 2 times 1 plus 1. If you find DC, you find AB. And then I would also check 9 times 1 minus 1. And I would also check using the 6 now, so 2 times 6 plus 1, and 9 times 6 minus 1. So you need to check to see if all of these give you a positive answer, then both of your x's will be the same. So what I want you to do is figure out if your x's are really 1 and 6. If they're not, just cross one off. If they are, just circle which ones or both that are correct. All right, number 3, you also see that right off the bat the triangles are not facing the same way. So triangle cat is the image, so you put a big fat I on cat, which means dog is the pre-image. And again, this question is asking for the value of k. So what I would do is just pick a side from the image. C to A corresponds to DO. All you do, remember k is image over pre-image. So you would have to, pick the side from the image, put it over the pre-image, and I would like to see a simplified fraction or a decimal. All right, so make sure you read this question correctly because a lot of you guys are getting it wrong on your quiz. So triangle PIG has side lengths 16, 20, and 24. Decide if the transformation will produce a similar or congruent triangle to pick. So similar, remember that's multiplying or dividing. Congruent would be adding or subtracting. So I do not want numbers here. I simply want an answer of similar or congruent. Using what I just told you, that a similar triangle is when you multiply or divide numbers. Congruent triangles when you add or subtract. So from that, I really just want to see the word similar or congruent next to each selection. All right, look at the figure at the right. Hopefully you notice that it is an overlapping triangle. Select which statement will produce sufficient information to prove triangle ADC is congruent to triangle EBC. So that's going to tell you the triangles you want to redraw, because when you see overlapping triangles, always a good idea to redraw. And notice it says select all that apply, so we could have more than one answer. Alright, so first things I'm going to do is redraw and highlight my triangles. Okay, so notice you already have some angles marked. Okay, and then I believe that was the C up there, A, D. So notice that is triangle ADC. Okay. Alright, so you want to mark the information they had already given you. They had given us angle A congruent to angle E. Then you want to look for anything that's repeated, and since only one letter is repeated, we know that this angle is also congruent to itself. So far we know angle A is congruent to angle E, and we can use one letter because there's only one angle at that letter. But here we have to use angle ACD, is congruent to angle ECB. Okay. So we're trying to give one additional piece of information to make sure our triangles are congruent. Obviously we have angles, so we're only going to be working with AAS or angle side angle, because there's no AAA, there's no AAA, there's no side lengths given, so if we give one more piece of information we won't have all the sides. Okay, so I just start looking at one triangle. If I want to use ASA, I would have to have AC, segment AC congruent to segment CE, which is up there. Okay, so I used angle, side, angle. If I want to use angle, side, angle, side, I would need an angle, and a side. So that would be segment CD congruent to segment CB. And then you could go the other way. You could go angle, side, which would be side AD congruent to side EB. Alright, number 6, you really got to make sure you read the question. The size transformation with magnitude 1/4. So you're applying a size transformation of 1/4 to segment AB to get segment CD. Okay? What they give us is CD. So we know 1/4 of AB has to equal 15. Because the question wants AB, not CD. So to get rid of that, you would multiply by the reciprocal. So we will be checking to make sure that you can now say AB equals. It should be a number. Alright, the last question, you have figures at the right. So measure of angle T, you should definitely be able to find that based off of missing angles in a triangle. You should also definitely be able to find measure of angle E. Or you could use corresponding angles of similar triangles are congruent. So we'll be checking that before you turn this in. So then they want to know which theorems can be used to prove triangle PAT is congruent to KEF. So what I'm going to do is write down all 5 and we're going to do some process of elimination. Alright, the first one we can definitely eliminate is hypotenuse leg, because in order to use hypotenuse leg you have to have a right triangle. So we have no right triangle, so that's gone. Then check side, side, side. In order to have side, 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 you have to have all 3 sides. We don't have all 3 sides, so we can't do that. Now you got to start looking at this crazy stuff. I actually made a mistake. I want to change this 4.5 to 5, because obviously it's going to go to segment EF. Alright, so please make sure you made that change. Now here, you should know angle T, so you do know this angle, and you should know angle E. So you know what they are. Hopefully you found them correct. So looking at this, you have an angle, a side, and an angle. Okay, so this one could work. Or you have an angle, side. So that one works. So what you need to decide is if SAS works. If it doesn't, cross it off. If it does, put a little check mark. And then voila, we are done.